break. Today we're going to talk about proportional relationships. So two quantities have a proportional relationship if there is a constant number or rate. Remember that word rate, like our ratios, that when multiplied by the first quantity gives the second quantity. All right. Now the constant number what it's being multiplied by. The constant number is called the constant of proportionality, known as variable K. All right, and two quantities that do not have a constant rate have a non-proportional relationship. So this is going to look a little bit different than our ratios. Our proportional relationships are going to be slightly different. Now, I'm going to show you two tables, one for Merrick and one for Caroline. So Merrick, minutes, points, rate. So for 1, 2, 3, and 4 minutes, Merrick has 8, 16, 24, and 32 points, and each of these have a rate of 8, right? 1 times 8 is 8, 2 times 8, 3 times 8, 4 times 8 is 32. So this type of relationship is proportional. For Caroline, however, minutes, points, rate. For 1, 2, 3, and 4 minutes, she has 8, 14, 24, and 36 points. So 1 times 8 is 8, 2 times 7 is 14, 3 times 8 is 24, and 4 times 9. So this type of relationship is non-proportional. That rate did not stay the same, so it's non-proportional. So you're going to determine whether the quantities in each table or graph represent a proportional relationship, and if yes, give the constant of proportionality. or k, what is it being multiplied by? So if we had minutes and laps, 1, 2, 3, 4, we had 3, 6, 9, and 12. So 1 times 3, 2 times 3, 3 times 3, 4 times 3. So yes is proportional and k equals 3. Now if we have gas to miles, 2, 52, 5, 130, 9, 234, and 16, 4, 16. So 2 times what is 52? 26. Is 26 times 5 130? Yes. 26 times 9. Yes. And 26 times 16? Yes. So if you can't do that in your head, you may need to divide the bigger number by the smaller to see what that constant rate is. So yes, it is proportional, and k equals 3. So if we're looking at another one, right, so let's write that down. To test for a constant rate, divide the second quantity by the first quantity. If it's consistent, then this is the constant of proportionality. Okay, I know that's a lot. So buses to students, if we had 1, 3, 6, and 8 buses, to 58, 156, 336, and 472. So I'm going to take this number divided by that number. Well, that one was easy. 3 into 156. 3 goes into 15 5 times. 2 times into 6. So already we know it's going to be a no, right? 3 goes into 35, 56 times. So the first 3 were different. 8 goes into 45, 59 times. So that's a big fat no. There is no constant of proportionality with that one. There is no proportional relationship. Now, if you have a chart you will have the same rate between points. It's a little bit harder for me to show here. But if it's going up at the same rate, and there's about the same amount of here, if our stair steps look even, then it would be yes, and whatever that was, so whatever we're multiplying the x by, or this would really be y value divided by the x value, gives you your k. here. So remember, this is our y-axis and this is our x-axis. So if this was 1 and this was 6, 6 divided by 1 is 6. If this was 2 and this was 12, 12 divided by 2 is 6 again. So that's going to be our k. Our k would be 6 here. However, if we had a graph that was kind of loosey-goosey, maybe we had one here, we had one here, and then we had one here, and then we had one here, and then it was kind of all over the place, then it would be a no. There would be no constant rate or constant proportion, no constant of proportionality. There you go, that's a big word for you. Big words for today. Oh, first day back. All right. Hopefully that is helpful. Let me know how I can help